Hi, everybody, and welcome back. So the last thing that we talked about was string extraction, and we said that that was well. So what's interesting about all of these functions in Stringer is a lot of them do very different things. Like they're you would use them for very different problems. And many times when I've been interacting with string manipulation functions, I will use just one part of Stringer and not touch any of the rest of Stringer. But then there are other cases where I have to use a lot of the functions in the Stringer package. So trimming and padding strings is another one of those instances where a lot of times you're not going to need to do this, but every once in a while it's going to be one of those things, and it just out of nowhere you're like, oh my gosh, I'm so glad I learned how to do this because it's super valuable for this one very niche thing. So one of those, well, let's talk about the functions that we need to learn, and then I'll go through a couple of niche examples of when I've had to use each of these functions. So string length, that's computing the number of symbols in a string. So maybe it's letters, maybe it's numbers, maybe it's spaces, maybe it's like the period sign or an asterisk or an ampersand or something. But basically, how many items are there in this string? That's the string length function. The string trim function will remove spaces from the start and end of the string. There's also another function called the string, I believe, let's see, and like string truncate, I believe. We'll look at it in just a minute. And then string pad. This is if for whatever reason, so let's say up above we had like those heights or weights where some of it was 2 units wide, others was 3 units wide. In order to make sure that all of the numeric information was 3 units wide, because we're not expecting to have any patients that are more than 999 pounds, for instance. So you would say, okay, well, I only need 3 units for weight. Then we can pad the numeric information with a 0 on the left-hand side, and so that all of our information stays in the same like position in the string. And sometimes that helps out our string manipulation pipeline to have all of the strings have the same width. So let's get into this first one, and that's going to be string lengths. This one, I have often used string lengths when dealing with what are known as n-ary or binary words, where you have a collection of symbols and each symbol represents some observation in time or in space. So we can think about DNA and RNA, that each one of these letters represents a position in the genome. And so you've got a C for cytosine, and then an A for adenine, a T for thymine, and a G for guanine. So those are all at positions within like physical location. Like in your body, it's microscopically tiny, but these letters represent actual physical locations. So sometimes if we've got a string of letters that represent physical locations, you may want to find how long different components of them are, or just how long the string is in its entirety. So that's where the string length function will come into play. So right here, if I've got this DNA strand, how many nucleotides are in the strand? We've got 12. If you've got attendance data, for instance, so you've got class attendance, they were either present or they were absent, and that's represented by this character string, then we say, okay, well, they were present in class for all of these weeks, they were absent here, and then they're back to being present in class. How many weeks of attendance data do we have? Oh, we have 8 weeks of attendance data. So the lengths function, again, not super complicated, but it's just every once in a while you end up, you may find that you need this function. So it's here for us to know about. Trimming strings. This one comes up. I'm going to give you an example of when I've had to deal with trimming strings. Whenever you deal with computational biology or bioinformatics, sometimes you end up with incredibly long names of chemical compounds or incredibly long names of biological pathways. And in those cases, if you try to build plots, you're going to have a legend right here where you've got this huge legend, and then the figure fits right here in the screen. You got that much space left for the figure, and most of the figure is taken up just because you've got these legends that have like hundreds of character strings in them, because they're very long chemical compound names or very long biological pathway names. So here's an example. This is a title of a novel that's pretty short, and this is a title of a novel that's reasonably long. And we can see here that R is going to take up a whole bunch of space. You see all this dead white space over here that's taking up a whole bunch of space in your manuscript, in your paper, and doing absolutely nothing with it simply because one of the titles is very, very long, okay? So one of the things that we can do is we can truncate. So this is the string truncate command, and we say, okay, we only want to show the first 15 characters, okay? So I was like, okay, well, how many letters are in Frankenstein? Okay, it's about 15. Sure, show the first 15 characters. And we see here, now we get, you notice that this figure is a lot wider. So we've got more space on the page to actually display the figure because less space on the page is taken up displaying this giant title, Frankenstein or the Modern Prometheus. So now we're just doing like Frankenstein. The book is Frankenstein versus the book is Germinal. So the string truncate, I have ran into this. I think those are the two instances where we were making ggplots and we had to fit very long labels onto the page, or very long pathway, like biological pathways, or very long molecular compound names onto a page. And we ended up having just like a number where it would be like A15 or something, and then the rest of the name, but it would truncate most of the name. And then we included a table as supplemental material where it says, okay, A15 matches, and then it shows the actual giant long compound name or the giant long pathway name so that people could actually read the figure if they needed to. They're like, oh, I'm really interested in this particular node on the graph right here, and it says B26. What's the compound for that? And they go down to the table and they look at it and it says, oh, B26 is some polysaccharide, whatever. But a lot of times you want to use string truncate. I have used it more often when displaying information in either ggplot, or if you guys eventually learn how to use Shiny, you can display information a little bit more compactly without having the legend of the figure resize and take up a whole bunch of space on your screen. And you don't end up with this huge chunk of dead white space above and below the legend. One other thing, so I said there were these three functions that are super helpful utility functions, and then finally string pad. So string trim, which it's the function is string, the function we ended up using was string truncate. String trim, it's super boring. It literally just removes white space from the start and end. Sometimes it's helpful, but I think I've used it maybe twice ever. So yeah, if you find yourself needing to remove a whole bunch of extra white space, string trim is your friend. Then finally, string pad. And this one has like a pretty niche use as well. And that's if you have a whole bunch of files on your computer and you're writing file names. So you've got like this giant batch data analysis and you're going to end up saving 500 results files to your computer. And you want to name those results files from 1 up to 500. Well, here's the thing. Your computer is going to do an alphanumeric sort on those file names. And if you're not careful, it's going to put the 1s, the 10s, the 11s, the 100, the 110, 101, 111, like all of the numbers that start with 1 are going to go first. And that's not what you wanted. You wanted it to go 1, 2, 3, 4, 5, 6, and then all the way down, and then 100, 101, 102, 103. But you want there to be like this ordering of the numbers. And the way that you can force your computer to preserve the numeric sorting properties even in a file name, because that file name is going to be character, which means it's going to be sorted like it was letter information, like alphanumeric information rather than just numeric. And we know that the order is 1, 2, 3, 4, 5, all the way up to 9, then 10 and 11. But because it's as a character string, the computer just sees this and says, okay, we're going to sort this alphanumerically now. And so you get the numbers out of order. The way that you would fix this is you would say, okay, I'm going to use the string pad command to add zeros to the front. So this will be 001, 002, 003, 4, 5, 6, all the way up to 010, right here, 010, 0, 1, 1. And that's going to force these numbers to be in the order that they're supposed to be in if they were actual numbers, but still allow the computer to interpret these as pieces of character string information. And that'll be all for this section. We'll pick back up. Actually, no, this next section is pretty short. So I'm just going to talk to you about this. So far, everything that we've done has been to pull a string out of a data set. So if you go back up here in this object, this is an atomic vector character strings. It's just a whole bunch of character strings. When we looked at the pattern, the use patterns, we said, well, the first thing that we needed to do was pull out this use pattern this use pattern column. So this is a column of a data set, and we need to pull it out in order to work with the string itself, not the tibble that we're working with. Stringr functions do not work directly on tibble objects or data frame objects. Stringr functions work on string, atomic character strings, okay? So in order to work on string information that are inside of tibble objects, so we're gonna make this data set right here. This was the heights data set. So we have the heights for females, the heights for males, and I created an indicator that says whether or not they were male or female. And now what we're going to do is we're going to go through these steps. I want you on your own time to go through these one by one, line by line, to make sure you understand what step 1 is doing, what step 2 is doing, what step 3 is doing, and what step 4 is doing. But notice my string manipulation functions happen inside of a mutate call, okay? Because the mutate call will allow us to operate within the column by creating a new column. So we're creating a new column called units that are the last 2 entries of the heights column. And then I'm also using mutate to create another column called value that are the numeric, the 2-digit numeric information in the heights. And so I'm basically taking my heights column and creating 2 additional columns. One is called the value, one is called the units for that value. And then I'm changing the value because it's still string information here. I'm changing it to numeric because it doesn't have the units anymore. It's just numbers, okay? So I want you to walk through run this code on your own time, go through it step by step and make sure you understand what is happening, okay? So I've seen a lot of people whenever they're working in tidyverse style code, and they're first learning string manipulation. They think, oh, well, I've got a tibble, and there's string information in the tibble. I can call these stringer functions directly on the tibble, and that is not going to work. The first argument of the stringer functions is always just an atomic character string. It is not a tibble. So if you want to do string manipulation inside of a tibble, you've got to work through mutate. You got to use the mutate to work on this. So we've got our clean heights. So we started off with our heights. So again, run this code on your own time. Look at where we started. Look at where we end with our clean heights data set. And then we can use a ggplot, and we can say, okay, the females, those are the females over here. Sex assigned at birth is female. That's true. They are shorter on average than people who were assigned male sex at birth. Okay, so here's my exercise for you, and this is again a longer exercise. We've got now basically all of the tools that we need to join the food stamp data that we got from the American Community Survey to the zip code data sets for Miami-Dade, Broward, and if you grab Palm Beach or another county, you can add that information as well. We have the ability now that we can join these data sets. We can do the string manipulation to clean up the zip code columns in the 2 data sets to make sure that they can match. And then you learned about the joining functions in the dplyr lesson, and then also the supplemental lesson that we don't have videos for because it's a guest lecture. And you've got the ability now where you can do some analysis of the South Florida counties versus the other counties and start to wrap your head around, is there something going on? Is there something different about how we live in South Florida, particularly related to poverty and food stamps? And and all sorts of different things. It's some demographers talk about South Florida as being like there's a lot of multi-generational families that live in South Florida compared to the rest of the state. So you have the skills now, you have the tools now between the stringr lesson, the dplyr lesson, and the ggplot lesson, and all of this other stuff that you can go through and you can start investigating this data. So that's what I want you to do. This could take you a couple hours. And I want you to work on it with your partners and so forth, and see if you can wrap your head around what's going on specifically in South Florida, and if there's anything different about the food stamp usage in South Florida, or what's driving it, or maybe not necessarily what's driving it, because that requires like a causal understanding of causal things, but is anything different about it? And start exploring the data. See if you can see what you can find, if you can find anything interesting. All right. Next time we will talk about functions and control flow. So see you.